Good morning, seventh graders. This is Miss Valero here. I teach math on Team 7B upstairs, for those of you who don't know me, or maybe you've seen me in the lunchroom. Today, I'm going to do a quick demonstration with you on finding volume of a rectangular pyramid and a rectangular prism. So what I've done is taken an example from the Carnegie textbook. So if you have your textbook or you would like to download the nets with us to do this activity at home, you can, or you can just follow along with my demonstration. I'm working on page 108 through page 111 in the Carnegie text. So here you can see we have a net of a figure. This is figure A. This is the dotted lines are where you fold, and then the dark lines would be where you cut. So if we cut out the net and construct it and tape the edges, you can see it forms this shape. I'm going to get tape on here. Okay, so here's our first shape that we constructed. And then this is the second net. If you look at this shape, it's just that doesn't have the top, because we're going to do volume today, and volume is how much will fill up a space inside. So we need to be able to fill that. And then for this shape, if we fold it on the dotted lines, and tape the edges together as best we can, we have this shape. As you can see, they are different. So the first question would be to name each of these solid figures. This first one would be a rectangular prism. It's a prism because it has the base that is the shape of the rectangle. And then all four sides go straight up, and the top would be the same exact shape as the base. So it's base 1 and base 2. So that makes a rectangular prism. And then here, you see this shape here. This shape also has a rectangle for the base, but rather than the corners or the vertices of the rectangle going straight up, they come to a point. We call this a rectangular prism. We look at the two together, we can see that they're the same shape and size of the base, and they are actually the same height as well. So the only thing really different about them is that this one comes to a point, so it lacks that top base that is identical to the bottom, whereas this one has it. So we call this a pyramid, a prism, and this a pyramid. Okay, so now for this demonstration, we're going to determine how many of these pyramids would it take to fill this prism. So I just happen to have some yellow keys. Do this best we can here. So this would be 1. And again, remember that the base is the same size. So the area of the base, the length and the width of the base is the same for both shapes. 2. That's 3. 1 fell out. Okay. So what can we conclude about the volume or the amount of space something takes up from this, the prism, and the pyramid? Well, if we were to compare the volumes, we would say that it would take 3 times the volume of the pyramid to actually fill the prism. And in order to write this as an equation to show the relationship between the volume of those, we would have to think about the base and the height, because the volume is how much fills the bottom and then fills it up. So let me try and share a screen with you, which would be our Carnegie text pages. Okay. And again, like I said, this is from the textbook. So if I go to page 109, which is to write the equation, we can write the equation for this relationship by saying that the volume and then I use the parentheses, capital B is for volume. The volume of the, and I'm going to put REC here because it's a rectangular prism. The base is rectangular. The volume of a rectangular prism is equal to the length times the width, which is the base, times the height of the pyramid. And then you would find another way of writing that is the area of the base times the height, right? And that's for the prism, the one that's this one here. Okay, so now if we're trying to find the volume of the rectangular pyramid, I'm just going to write it out like that. And I'm going to put rectangular, R-E-C-T, because the base is the rectangle shape, this part here. Well, again, it's going to be the length times the width, which is the area of the base, times the height, because you have to fill up the shape. But we noticed that it took 3 times. So you would have to divide this by 3 in order to get the volume of just the prism itself. So another way to write that would be the area of the base, which is capital B. Capital B represents area of base, whereas little b would just be one side of the base. So its area is capital B, which is the length times width, and I can just add that note here in a different color. This part here is area of the base. And then we will multiply that by the height and divide by 3, because it would be 1/3 the size for the pyramid. Okay, so sometimes you might see this written as 1/3, because 1/3 times anything is also divided by 3. So 1/3 the area of the base times the height. And that is how we have determined the formulas. Thank you for joining me. And in the next videos, we will practice how to solve some of these problems.